does an electric motor work? Direct current, DC. Let's take a wire, wrap it around the metal ball several times, and then create an electric circuit. This aligns the magnetic particles. This means we have just made an electromagnet. It has a north and a south pole. It can pick up pieces of metal and it can attract or repel other magnets. If you reverse the polarity of the voltage, the electric current flows in the other direction and the poles change places. If the electromagnet is mounted on the spindle and free to rotate between two permanent magnets, it aligns itself with the two side magnets. Now we swap the wires to change the polarity of the electromagnet. Like poles repel and opposite poles attract. If we keep changing the polarity, our electromagnet will keep spinning. To make the electromagnet stronger, we position a curved permanent magnet to the side. Instead of the metal balls with wires, we use a metal loop, the armature. If we connect our wires, we have a circuit with a magnetic field. Now the rotor turns until the opposite poles are facing each other. We can continue turning if we swap the wires as before. To the rotor we add a ring with gaps on the opposite sides, the commutator. It turns together with the armature. Now we connect the commutator to two brushes on the sides. The brushes will slide along as the commutator spins. They are spring-loaded so that they always maintain contact. The current flows from the wire through the brush, the commutator ring, the armature loop, and back through the other side. The brushes switch contact to the other side of the commutator ring. This means the electromagnet switches polarity. This causes the armature to keep spinning. It will continue to spin as long as it is connected to the battery. If we split the commutator ring and add another loop, this electromagnet will spin, the brushes will change their contact, and the next loop will be on. This keeps happening as long as our motor spins. It is almost like the loops will take turns as an electromagnet. Electric motors are stronger with more loops added to the armature. This is done by winding more wires around the armature. If the motor has stronger electromagnets, it develops more spinning force. And stronger torque means stronger electromagnets and faster spin. The part that does not move in an electromotor is called stator. In our example, it is two permanent magnets located on the side of the motor case. In this way, electric machines can be used as drive motors and get the customer's applications moving.